Here's a lesson for section 4.2, solving multi-step equations. Last lesson, we learned how to solve 1- and 2-step equations. In this lesson, we'll have to combine our knowledge of collecting like terms and solving equations. So, for the first example here, I have 3x plus 2 equals 2x minus 4. So you're going to notice here, I have a couple groups of like terms. I have a 3x and a 2x. Those are like terms because they have the exact same variable with the exact same exponent. And I have a 2 and a negative 4. Those are constant terms. I would be able to collect those together as well. So I have to apply my knowledge of collecting like terms and solving equations here. So step number 1, what I want to do, I want to get all the terms that have the variable onto one side of the equation. So I put a little note of that here. Start by moving all the variable terms to one side of the equation. So I want to, let's collect them onto the left side. So I want to move this 2x to the left side of the equation. So on the right side of the equation, I have a positive 2x. I know to move something to the other side of the equation, I must do the opposite. So to move it to the other side of the equation, I must subtract 2x. So I have 3x minus 2x. It became a minus 2x on the left side of the equation because on the right side of the equation it was a positive 2x. Plus 2 equals negative 4. Now that these are on the same side of the equation, I can collect them together. You can't collect like terms together until they're on the same side of the equation. So now I have a 3x minus a 2x. That gives me 1x. I still have the plus 2 equals negative 4. Now this looks just like a question from yesterday, or from last lesson. Now I want to isolate the variable. I want to isolate the x by moving this plus 2 to the other side. And I remember, to move a term to the other side, I must apply the opposite operation. So the opposite of adding 2 is subtracting 2. So to move to the other side, I must subtract 2 from the other side. So what I'm left with on the left side of the equation is just the x, because I've moved the plus 2. And on the right side, I have negative 4 minus 2. So x equals negative 6. And you can plug that, don't forget, you can plug that back into your original equation and make sure that if x is negative 6, that makes this equation true. It makes the left side equal the right side. I'll do that for this question. I won't do it for all of them for this lesson, though. So I have 3x plus 2 on the left side of the equation. So 3 times negative 6 plus 2. Let's see if that's equal to 2 times x. So 2 times negative 6 minus 4. Let's solve this. So I have 3 times negative 6 is negative 18. Plus 2, and on the right side I have 2 times negative 6, which is negative 12, minus 4. Negative 18 plus 2 is negative 16. Negative 12 minus 4 is negative 16. So the left side equals the right side. So the value x equals negative 6. Negative 6 is the value of x that makes this equation true, so this is the solution to that equation. Number 2, I have 7 minus 2x equals 8 minus 5x. So remember, start by collecting the variable terms onto one side of the equation. It can be the left or the right. I'll just kind of get in the habit of bringing them to the left. Then move the constant terms to the other side of the equation, and then isolate the variable. So let's do this. First thing I want to do, bring the variable terms to one side of the equation. I'm going to bring them to the left. So on the right side of the equation, I have minus 5x. I know to bring it to the opposite side of the equation, I must do the opposite operation. So I must add 5x to the other side of the equation. So I have 7 minus 2x plus 5x equals 8. Because I've brought this negative 5x to the other side of the equation and became plus 5x. Now I'm going to collect my like terms. I have a negative 2x plus a 5x. That gives me positive 3x. Now I'm going to isolate the term that has the variable. So I want to move this positive 7 to the right. So right now, 7 is being added to 3x. The opposite of adding 7 is subtracting 7. So to move this to the other side, I must subtract 7. So I have 3x equals 8 minus 7. So 3x equals 1. Now I want to actually isolate the variable. So I need to divide this 3 to the other side, because right now I have 3 times x. The opposite of multiplying by 3 is dividing by 3. So to bring this to the other side, I must divide by 3. So I have x equals 1 over 3. And leave your answer as a fraction, 1 over 3, that's in simplest form. So our solution to this equation is 1 over 3. And you can plug that back in and make sure that's the correct answer if you would like. Alright, number 3. 5 minus 3m equals negative 2 minus 2m. Try this one on your own quickly. Press pause and try it now. Okay, now that you've had a chance to try it, let me go through the solution for you. So, step number 1, bring all the terms that have the variable to one side of the equation. So bring all the variable terms to one side of the equation. To keep it consistent, I'll just keep bringing them to the left side. So I have 5 minus 3m equals negative 2 minus 2m. I want to bring this minus 2m to the other side of the equation. On the right side, I'm subtracting 2m, so that means on the left side, I must add 2m. So I have 5 minus 3m plus 2m equals negative 2. I'm going to collect my like terms. I have a negative 3m plus a 2m. That gives me negative 1m. Now I want to isolate the term that has the variable. So I want to isolate this negative 1m by bringing this positive 5 to the other side of the equation. The opposite of positive 5 is negative 5. So I'm going to subtract 5 to bring it to the other side. So I now have negative 1m equals negative 2 minus 5. So negative 1m equals negative 7. Now isolate this m. I want to get the variable all by itself. So I want to move this negative 1 to the other side by applying the opposite operation. Right now, I have negative 1 times m. The opposite of multiplying m by negative 1 is dividing by negative 1. So I need to divide by negative 1 to bring it to the other side. So m equals negative 7 divided by negative 1. Negative 7 divided by negative 1. Negative 7 divided by negative 1. Negative divided by negative gives me a positive 7. And you can plug that back in and make sure that's the correct solution to the equation. So m equals 7. 7 is the value of m that makes this equation true. Number 4. So for this one, we're going to have to remember also distributive property, as well as our collecting like terms and solving equations. So step number 1 is we want to get rid of these brackets by expanding using the distributive property. So what I'm going to do, I want to get rid of these brackets by expanding this 5 to the x and to the negative 3. So distribute the 5 to the x and to the negative 3 to get rid of the brackets. 5 times x minus 3, you have to multiply the x and the negative 3 by 5. That gives me 5x minus 15. Now I want to get rid of these brackets as well. Remember, if you don't see a number there, you can think of there being a negative 1. I'm going to distribute the negative 1 to the x and to the negative 2 to get rid of these brackets as well. So negative 1 times x is negative 1x. Negative 1 times negative 2 is positive 2. Now, this is a question just like the ones before. On the left side of the equation, I already see some like terms I can collect together. So I'm going to do that first. So I have a 5x minus a 1x, that's 4x. And I have a negative 15 plus 2, that's negative 13. And this left side is equal to 19, it tells me. So what I'm going to do now is I'm going to isolate the term that has the variable. So I'm going to isolate the 4x by moving this minus 13 to the other side of the equation. The opposite of subtracting 13 is adding 13. So 4x equals 32. Now I'm going to isolate the x by moving the 4 to the other side. Right now I have 4 times x. The opposite of multiplying by 4 is dividing by 4. So to bring it to the other side, I must do the opposite operation, which is dividing by 4. 32 divided by 4 gives me 8. So x equals 8. 8 is the value of x that makes this equation true. And you can plug it back in and check, don't forget. So let's go ahead and actually check our answer for this one. Because it was a lengthy question, well, let's make sure that we did all the steps right. So let's see if 5 times x minus 3 minus x minus 2 equals 19 if x is 8. So 5 times x minus 3 minus x minus 2 equals 19. Okay, so let's check. If x is 8, does the left side of this equation equal the right side? So I have 5 times 8 minus 3 minus 8 minus 2 equals 19. So 5 times 5 minus 6 equals 19. Make sure you're following the correct order of operations here. So let's do the multiplication first. 25 minus 6. Let's see if that equals 19. 25 minus 6 is 19. So 19 equals 19. So the left side equals the right side. So we did the question properly. 8 is the correct answer. Okay, next question. First step, whenever you have some multiplication here with brackets, whenever we're multiplying a monomial by a polynomial, let's get rid of the brackets by using our distributive property. So let's get rid of these brackets by expanding this expression using the distributive property. So distribute the 2 to the x and the negative 3. That gives me 2x minus 6. And then on the other side of the equation, I have a multiplication I should do here to get rid of the brackets. Distribute the negative 3 to the x and the 5. Make sure you distribute the negative 3. Don't forget that negative in front there. Negative 3 times x is negative 3x. Negative 3 times 5 is negative 15. Now let's bring all the terms that have the variable to one side of the equation and all the constant terms to the other side of the equation. Let's see if we can do this in one step this time. So I have a negative 3x on the right side. When I bring it to the left, it's going to become a positive 3x. And on the right side, I had a negative 15 minus 6, but I need to bring this negative 6 to the other side of the equation. So on the left side, I have minus 6. That means on the right side, I'm going to be adding 6, because adding 6 is the opposite. Now let's collect our like terms. 2x plus 3x is 5x. Negative 15 minus 6 is negative 21. Plus 6, I'm back to negative 15. Now isolate the term. So we've isolated the term that has a variable. Now actually isolate the variable. So to get x by itself, I need to bring this 5 to the other side. Right now I have 5 times x. The opposite of multiplying by 5 is dividing by 5. So to bring that 5 to the other side, it becomes dividing by 5. Negative 15 divided by 5 is negative 3. So x equals negative 3 is the solution to that equation. Negative 3 is the value of x that makes the left side of this equation equal the right side of this equation. Try this one on your own. Pause it now and try it. Okay, now that you've tried it, I'll take it up for you. Whenever you have brackets, okay, so whenever we have a monomial multiplied by a polynomial here that we can expand out and simplify it, we do that first. So let's use our distributive property and get rid of the brackets. Always get rid of the brackets first if you can. So distribute the 5 to the 5x and to the negative 13. Remember to multiply a monomial by a polynomial. Every term in the polynomial must be multiplied by the term in front of the brackets. So 5 times 5x is 25x. 5 times negative 13 gives me negative 65. And that equals 23x minus 13. Okay, bring all the terms that have a variable to one side of the equation and bring all the constant terms to the other side of the equation. So I'll bring this positive 23x to the left side and bring this negative 65x to the right side. So when I bring the positive 23x to the left, it's going to become negative 23x. And when I bring this negative 65 to the right, it's going to become plus 65. So 25x minus 23x, that'll give me 2x. And then I want to do negative 13 plus my 65, and that'll give me 52. Now I want to get the variable all by itself. To get the variable by itself, I must move this 2 to the other side. So to move that 2 to the other side, I'm going to have to divide by 2. Because on the left side, I had 2 times x. The opposite of multiplying x by 2 is dividing by 2. So to bring that 2 to the other side, I had to divide by 2. 52 divided by 2 gives me 26. So x equals 26 is the solution to this equation. 26 is the value of x that makes the left side of this equation equal the right side of this equation. And don't forget, you can plug it back in and check and make sure that's true. Okay, let's do an application question now. So the perimeter of a given rectangle is 50 centimeters. Determine the length of each side of the rectangle. So first off, to do this question, I have to remember that the perimeter of a rectangle is equal to 2 times the length plus 2 times the width. It gives me the length, it gives me the width, and it gives me the perimeter. Okay? So I can plug in everything I know here and be able to solve for x, and then that will tell me what the length and what the width of the rectangle are if I know the value of x. Okay? I know the length is 4x plus 5, so if I figure out what x is equal to, I will be able to figure out what the length actually is. And follow the similar reasoning to figure out what the width is as well. So let's plug in everything we know into this equation for the perimeter of a rectangle. I know the perimeter is 50. I do 2 times the length. I know the length is 4x plus 5. So I need to do 2 times this entire thing, 2 times 4x plus 5. So I need to put that in brackets. So I remember to multiply this entire thing, the entire length, by 2. Plus 2 times the width. And I know the width is 3x minus 1. So I need to do 2 times 3x minus 1. Okay, now I have an equation with one variable, and that variable is an x. I could solve this equation and figure out what value of x makes this equation true, and then I could use that value of x to determine the length and the width. So let's go ahead and do that. Whenever you see brackets, we want to get rid of those first step. So to get rid of these brackets, I need to use the distributive property to do the multiplication. So I have 2 times 4x plus 5, so I need to distribute the 2 to the 4x and the 5. That gives me 8x plus 10. Plus, I need to distribute the 2 to the 3x and the negative 1. 2 times 3x is 6x, and 2 times negative 1 is negative 2. Now I need to collect all the variable terms to one side of the equation and all the constant terms to the other side of the equation. Since I already have all the variable terms on the right, I'm going to leave them there. Okay? And all the questions previously, we've brought them to the left. But this is a good example because I'll show you that it doesn't matter what side you bring the variable terms to. We can bring them all to the right. That's fine as well. So since they're already on the right, I'll leave them there and I'll bring all the constant terms to the other side of the equation. So I'm going to bring this plus 10 to the left and it will become minus 10. And I'll bring this minus 2 to the left and it will become plus 2. And on the right, all I'm left with is the 8x plus 6x. Now let's collect our like terms. 50 minus 10 is 40, plus 2 is 42. And I have 8x plus 6x, that gives me 14x. Now I need to get this x by itself by moving this 14 to the other side. Right now I have 14 times x on the right, so to bring this 14 to the left, I must divide by 14, because dividing by 14 is the opposite of multiplying by 14. So on the left, I have 42 divided by 14 equals x. 42 divided by 14 is 3. So that tells me 3 equals x. That means that x equals 3. Okay? So the value of 3 is the value of x that makes this equation true. Okay? So if I plugged in 3 for x, it would make the left side equal the right side. So now that I have that, now that I know that x is equal to 3, I can plug that in for x into the expression for the length and the width and determine the actual length and width. So I'll do that for us. So if x is 3, I know length is 4x plus 5. I'll get a new page for us here. So I know length equals 4x plus 5, and I know x is 3. So 4 times 3 plus 5, which is 12 plus 5. Make sure you do bed math, multiplication before any adding or subtracting, which is 17, and I think we're in centimeters. Yeah, we're in centimeters. So the length is 17 centimeters, and my width is 3x minus 1. Width is 3x minus 1, and I know that x is 3, so 3 times 3 minus 1, which is 9 minus 1, which is 8. So my length is 17 centimeters. My width is 8 centimeters. So those are the dimensions of this rectangle. So here's a review of everything we did. So to solve an equation involving multiple terms, collect the variable terms onto one side of the equation, doesn't matter which side, and then collect the constant terms to the other side. Okay? Then collect all your like terms and isolate the variable. To solve an equation involving brackets, you may need to expand the brackets first. So do your multiplication first and get rid of the brackets using your distributive property. And don't forget that you can check your solutions. Okay? So whenever you do any worksheets or tests for this chapter, you can always check your answers and know if you did the questions right. If you have any questions, make sure you let me know, and that's it for that.